Today we're going to solve the integral of y times y squared plus 1 to the fifth, this in parentheses, all of this to the fifth, dy from the bounds 0 to 1. So right away, I see parentheses, so I want to make y squared plus 1 my u, so we're going to use u substitution to solve the integral of this function. So I make this, set this equal to u. Then the next step is to find the derivative of u, of this function. And then, so we make 2 go out in front, so there's a 2, and then there's y. Then we subtract 1 from the exponent, so that just becomes 1, so that's where the 2y comes from. And then we take the derivative plus the derivative of 1, which is just 0. So it's just going to be 2y, and then dy, because we're taking the derivative in respect to y. Then we look back at our originally function, and we see that we have a y, but we don't have a 2 in here. So to set it true to this equation, since we don't have the 2 in there, we're going to have to divide this by 2. So then we get 1/2 du equals y times dy. Now here, if we look back at our original function that we're taking the integral of, we see y and dy in there. So whenever we go to the next step for u substitution, we can see that we set du, we just plug this in for y dy, and then we plug in u for this. Since this is our u, it's just going to be u to the fifth, and then 1/2 du is just, we're going to plug that back in there for the dyyy times y. But whenever we go to that next step, we have to change our bounds because it's not in terms of y, it's in terms of u. So to do this, all you need to do is see your first, wherever your bound starts at. So it's y equals 0. So all we have to do is plug it back into this u equals y squared plus 1. So 0 squared equals 0 plus 1. So in this case, u would equal 1 whenever y equals 0. And we just do the same thing for y equals 1, since this is our other bound. So we just plug in 1. So 1 squared is just 1. 1 plus 1 is 2, so u equals 2 whenever y equals 1. So here you can see that those are our new bounds. Then we see that the 1/2, we can pull that out because that's a constant. Then we're left with u to the fifth times du, with the bounds from 1 to 2. So then we just continue to take the integral, which in this case, to take the integral of u to the fifth, it would be u to the sixth divided by 6. You divide it by whatever your exponent ends up being. So in this case, the integral of u to the fifth would be 1/6 times u to the sixth. And we keep the 1/2 that's out front. We don't take the integral of that. So it's 1/5 times, in parentheses, 1/6 over u to the sixth. And then we still have to evaluate this from the original bounds with the u substitution, with the u in terms of u from 1 to 2. So here it's just plugging in, and so first we take the top bound, so it's going to be 1 times 1/6 would just be 1/12. And then we substitute 2 in for u, so 2 to the sixth would be equal to 64, and then times that by 1/12. And then we subtract that by the lower bound, which would just be 1, so it'd be 1/12 in parentheses, 1 to the sixth would just be 1. So here we get 12 times 64 minus 1/12. And here we can see that 1/12 times 64 minus 1, 12 times 1. And then if we continue on, it's just simple math. It's 64 twelfths minus 1 12th, which equals 63 twelfths. And that is the answer.